Okay, here are the practice problems that you asked for. I'm trying this in some new software and an app that a colleague of mine from Indiana showed me, so there may be a few glitches, but bear with me. I quickly want to remind you of the formula, the Shannon-Weiner index, for calculating species diversity, and also remind you how to how to be able to calculate log base 2 of a number when your calculator has only log base 10. And it's basically taking log base 10 of the number divided by 0.301, and that's what you can see down here. Now for the first practice problem. This is a very simple problem in which you went out and sampled songbirds in a forest, found 5 different species, and the number of individuals in each species are shown here. At this point, you should pause the video and try to work out the problem on your own, and then restart the video and watch as I work through this one. And I'm going to work through each of these cells on this table individually so you can see exactly how I got the calculations. On the remaining 2 problems, I will add the numbers in each of the cells, but I won't take the time to work them out, each one individually, while you're watching. So it will give you something to check against. The first thing that you need to do when working these problems is to add up the total number of individuals in your sample. And in this case, you've got 5 plus 11 plus 18 plus 1 plus 3, and altogether that equals 38. Then to determine P sub I, you take the number of individuals of each species and divide it by the total of your sample size. So for cardinals, it's 5 divided by 38, which equals 0.132. Oops. Now I'm going to round 3 decimal places in all of these. So at the end there are slight differences in your number and mine. It could be due to rounding error, but the differences should be no more than a few thousandths. Alright, now for the next column, log base 2 of P sub I, you take that value of pi and you determine log base 10 of that, then divide by 0.301. So log P sub I, which in this case, just go ahead and put that value in. It's log of 0.132 divided by 0.301. And that value, erase this, that value is negative 2.927. And then to determine H for that particular species, you multiply those 2 columns by one another. And you get negative 0.385. Now I'm going to go down and fill in each of these cells on this problem. On the remaining 2 problems, I will just fill them in and you'll see the finished table. For robins, the proportion is 11 divided by 38, which equals 0.289. Log base 2 of that is negative 1.789, and then multiply that, get negative 0.518. For metal arcs, the proportion is 18 divided by 38, which is 0.474, and log base 2 of that is negative 1.078 times 0.474 equals negative 0.511. For bluebirds, the proportion is 1 divided by 38, and that equals 0.026. And the log base 2 of that is negative 5.248. And then the product of those two is negative 0.138. And finally, for tufted titmice, the proportion is 3 divided by 38, which is 0.079. And the log base 2 of that is negative 3.663 times 0.079 is negative 0.289. Now finally, to calculate the species diversity for this population, you add up all of these here and multiply by negative 1. Remember, there cannot be a negative species diversity. And if you put down a negative for your answer on the exam, I will count it wrong. So adding up 0.385, 0.518, 0.511, 0.138, and 0.289, you get 1, and multiplying by negative 1, you get 1.841. So species diversity for this community is 1.841. This next problem is intended to show you that any way that you can get a sample of your community of interest, you can determine the species diversity. However, keep in mind that when we talked about mark recapture studies, the method of trapping or capturing is extremely important because there's bias in each method. And certainly in this scenario here, there is bias because, first of all, the fish community that you're sampling are only the predators. Secondly, different fish prefer different types of prey, and so the bait you're using makes a big difference. And thirdly, fish preferences change throughout the day. Certainly, largemouth bass may be less selective in the morning than they are in mid-afternoon, and so bait that you could catch them on in the morning may not work in the afternoon, and so forth. So this would not be a good sampling method, and in fact, the common way of sampling fish is to electroshock them. You mount what amounts to a large electrode on the front of a boat, and you send current into the water, and it stuns the fish. They float to the top. You can identify them, take whatever measurements you need, and return them to the water, and they'll be just fine. Alright, with that being said, we'll now move to the problem. And in this problem, there are 7 different species that you caught. The number of individuals are shown here. And as before, you're going to want to total up those individuals and then go through and either work by columns or rows. It doesn't matter. And you should stop the video now and do that. I am going to add all of the answers into the table, and I'll start the video again, so when you click on play, you will see all of the answers and you can check to see if the answers that you got match these. Okay, so here's the filled in table. One thing I want to point out is that the column of P sub I, these proportions, if you added those up, they should equal 1 because this represents the entirety of your sample, or 100% of your sample. And so these together added up should be 1.00, which equals 100%. You might be off by a thousandth or so because of rounding, but it should be pretty close. Then, after I did this, the total of this column over here was 2.385 times negative 1. It was negative 2.385 times negative 1. So my species diversity index is 2.385. Now we'll move on to the last problem. Something a little more realistic, but the numbers in this last problem, the numbers for the numbers of species, not particularly realistic. I generated these numbers by a random number generator, and so there's very little chance you'd catch as many hognose as I show on here, or as many coral snakes. The rest of the numbers are pretty close. The coach whips would probably be higher. Same with rat snakes. Alright, so you should again pause the video, work the problem, and then when you start it up again, you'll see the filled in table. And I need to apologize, I forgot to include a row here at the bottom to put your Shannon-Weiner index, your final calculation, but I'll draw it up here near the top, somewhere up here when I'm done. So for this problem, the species diversity is 2.668. I want to point out something on this in case you didn't catch it before, but when the number of individuals is the same for 2 or more species, then all of these numbers are going to be the same. So on an exam, this can speed up your calculations. And finally, speaking about the exam, you will get a problem very similar to one of these 3. There won't be 7 species. It'll be probably somewhere in the neighborhood of 4, just because of the interest of time. And don't forget, you're going to have to do these on the Microsoft calculator on the computer, so make sure you practice with it so that you know how to use the log function. If you have any questions, as always, just come by and see me or send me an email and I'll see what I can do to help.